Hi all, and welcome to the Medical AI Lab Talk series. I am delighted that today we have Tom Jin presenting Building an Amplify Lambda-powered website on AWS. Looking forward to your talk, Tom. Take it away.
Perfect. All right. Thank you so much, Pranav. So today I will be talking a lot about AWS. And so we'll be doing a more hands-on demo today. I should share my screen. But I will also hopefully leave enough time, because I know a lot of you guys are building some projects on AWS, or at least using some AWS resources. And so, if you have any questions near the end, I am happy to answer them. Or if you don't have time, we can answer them offline as well. So this is a very similar presentation to what I did last year, except this time I'm going to be, again, a little bit more hands-on. And so hopefully today, by the end of our session, we'll be able to build this very simple website that's going to allow you to upload this NumPy file, which is basically a array containing a ECG, and we'll be able to visualize it on this website. We're going to be doing this in a serverless manner, which I'll talk about in a bit, and we're going to be using some of the latest technologies from AWS as well. And please feel free to stop me at any point in time. If you have any questions, just shout them out, because I don't think I can see all the controls at the moment. All right, so that's what we're going to be building. This is the architecture that we're going to be using. It's a serverless architecture, and what that means is that we're not going to be using any servers. So you might be used to using the deep cluster, so you're used to like just SSH into a machine and running a program there, and that's traditionally how websites are normally run. But we're going to take advantage of a serverless architecture, which has the benefits of meaning that you don't have to maintain any servers. You're completely using things like Lambda Functions, which are these giant orange blocks over here. Does everyone know what a Lambda function is here? If not, that's okay. Basically, a Lambda function is a piece of code that you'd be running that's not being run on a server, but it's being run in sort of like a container. And so you can call your function as many times as you want. And you're basically only paying for how much compute time you're using. So this is going to be very convenient, and be creating two Lambda functions over here. One Lambda function is going to be a pre-signer Lambda. The other one is going to be a parser Lambda. The pre-signer Lambda over here is going to allow us to gain a temporary token that allow our users to upload a file directly to S3. So this is the ECG file that we want them to upload. And the parser Lambda over here is what's going to take the file from S3, read it out, and send it back to the website for it to render on the web page. And we're going to be using React for our website. And everything's going to be fronted through this API gateway, which is essentially going to be our a REST API that allow us the website to call one of these two Lambda functions over here. Our Lambda functions are going to be producing some logs, which we're going to be storing in CloudWatch on the right here. And then finally, we're going to be using Amplify on the right, on the left here, to be able to host our website all in the cloud. So with that, and just before, I have a few more slides, but just before that, I'm going to be, I'm going to have to get a few things started. So this is going to be a hands-on demo. And what I'm going to be doing is I'm going to be using this repository over here. This should be a public repository, and I'll drop it into the Zoom chat here if you want to follow along. If I can find the Zoom chat. Here we are. And so what this is over here, I'm going to be deploying this. I'm going to be walking through a brand clean clone of this repository, and I'm going to be deploying it on one of our AWS accounts that we are using. So there are some instructions on if you wanted to deploy this in your spare time as well, and you can probably refer to the video afterwards. But let's get started. So I'm going to first clone this repository. Brand new file. I'm going to go into my folder. So let's do apps. Let's make a directory p3, and let's clone this. So git clone. All right, so I'm going to set up my workspace over here. So I've cloned it. I am going to go over here. And before I move on, you guys can see my screen, right? Like it's not too small or anything like that.
I can see it, but it would be nice if it were a larger font.
Larger font. Okay, I will attempt to do that. Does anyone know how to make VS Code larger? While I try to pull up my P3. Okay.
Control plus plus.
Control in VS Code. Ah,
yeah,
perfect. Okay, just a bit slow, but hopefully. Why is it I can only, there we go. All right, perfect. And I will attempt to make this a bit larger as well for you guys. All right, so I have my VS Code set up here. There's a couple directories. There's a backend folder. There's a front-end folder down here. The assets is just holding the README pictures, so that's not important. But the important thing is that in the backend folder over here, this is where we're going to be storing, if I can bring up my slide again, the backend folder is storing all the resources for these, what I call backend components. The front-end folder over here, this one, is storing all the code on the React website. So simple, very straightforward. We're going to first install our dependencies. I'm going to navigate to my folder. So I'm going to go to my backend folder. We're using npm as our package manager. So I'm going to just run npm install. And we can take a look at what's installing. So we can see our package.json file. So we're going to be installing a few very simple things, mostly Cdk. And I'll talk about what that is in a second while I get my front-end components installed. Npm install. Perfect. Okay. So while that's installing, I'll talk about what Cdk is over here. So Cdk is essentially our blueprint. So this is my Cdk stack. It's a blueprint for, where'd my PowerPoint go? It's a blueprint for creating all of these backend resources. So, yes, you could go to the AWS console, and I'll show you the AWS console right now. So for example, I have an S3 bucket, which is where we're going to be storing our files. I can absolutely come here and I can create a bucket from the console, but that is something that you would never do in production or in any industry settings, because you want to make sure that every single change that you make to your resource over here is version controlled. It gets to be reviewed, and you're able to track any changes that have occurred, as well as that we want to keep a blueprint in case we do want to deploy it on multiple accounts. So for example, a very good best practice that we do in our team is we have separate AWS accounts for every single region. And so this may not be applicable to you, but from an Amazon point of view, say you're in Europe, or you're running a service in Japan, or you're running a service in North America. Each of these, we call it, has a distinct region, and in each region has its own AWS account, because it helps us maintain separability between regions, to minimize blast radius. If something goes wrong, we're not impacting every region, we're only impacting the one region in one AWS account. Because of that, we have like dozens of AWS accounts, and in order to replicate the same architecture, we need a blueprint to do that. And that's what Cdk is for. Cdk is a blueprint that looks like this. They call them stacks. So you can have one or more stacks in your that make up your account. We're just going to do one single stack. And so you can kind of, if I can rearrange this properly on my screen, we can see that in my CDK stack over here, we're going to be defining exactly what you see on my screen. So what I have is, for example, this is the simplest thing we have is a bucket. So this piece of code over here is going to create this S3 bucket down here. And then we're going to be defining some properties like the bucket name, what kind of encryption we're going to use, what kind of access level we want. We can add some CORS rules. These are just going to allow us to publicly have the right kind of headers for file access when we're accessing files in this, or when we're uploading files to this bucket. And so that's what the rest of the components will do. But actually, before I do that, I'm just going to kick off a deployment because that does take a couple minutes. So let me just bring up my file over here, my terminal. Okay, so we've installed the front end, we've installed the back end. I'm just going to go back in the back end folder again here. And what I'm going to do is I'm just going to kick off a deployment. So I need to run Cdk Deploy all. So again, all these instructions are in your are in the README if you do want to follow along later. Okay, so while that's going on, sorry, I'm just going to go back here and explain the rest of this backend stack. So that was so I talked about the bucket. That's the one thing we're going to create. Now we're also going to create something called a VPC. So the VPC over here is this big green box that kind of surrounds all of these backend components. A VPC is a virtual private cloud. It keeps all of your compute resources within a private network. This is important if you're ever building something that you need to be HIPAA compliant. There's a lot of requirements that AWS sets out in order for HIPAA compliance. VPC is one of those components. And this is just standard good best practice. Now you need a VPC because you want all your compute resources to be isolated. So this protects your system from external attacks, for example, because by isolating your system, all your components communicate on a private network. So there is no internet access points. So no one's able to like directly access your Lambda functions. It's typically a little bit more important. Say you had a EC2 instance, so you actually had a running server. You want that server to be protected from the outside internet. So you wouldn't assign a public IP address. You would put it into a VPC, and then that server will communicate with all the other AWS services within this kind of virtual private network. So that's a super important thing to do. And that's what we're doing here with this VPC line. You'll see that what's nice about this blueprint is that you can reference things. So you can see the VPC is later being used like down here by our Lambda functions. So this is how we're creating our Lambda function, one of our two Lambda functions. This is creating the pre-signer Lambda from this one over here. We're going to be placing this Lambda function within our VPC, within our green box. We're also going to be creating a few more properties over here. So for example, obviously like where the code is located. So you can see, well, this pre-signer is going to be using code from, where's my mouse? From the Lambda folder, from this pre-signer. So this is the file name, this is the function name. So we're going to open up this. This is the pre-signer function. This is the function name that it's going to call. So I explained this briefly earlier. This is a very simple Lambda function that all it does is that it takes in the basically returns some temporary credentials for the user to upload to this S3 bucket. And so you'll notice that in this Lambda function, very straightforward. There's not a whole lot of, it's using standard imports. And it's also using something called Boto 3 or Boto Core. This is just the name of the AWS library for Python. And this is something that important note is I didn't need to install this because this will come natively on the Lambda itself. So once you run a Python Lambda function in AWS, you're going to have access to this directly. So that's the pre-signer function. This is the code. This is the CDK or the blueprint to create the Lambda function. You'll see there's some other properties like, oh, you know, we're going to need some timeout settings. We're going to need some memory, define our memory. You know, things like the role as well. So I skipped over the role, but you can see in the same file, it's creating a Lambda role, which basically gives the Lambda, saying, well, this Lambda function has permissions to do all of these actions. It can get files from the S3 bucket, it can put files, it can list files, but for example, it would not be able to delete files. And so this is another aspect of good practice. This is actually not the best kind of role that you want to create. You basically want to give each component the least amount of permissions for it to do its job. So if your Lambda function, for example, never needs to add files, you would not give it put object permissions. And this is, again, another layer of security that you're just protecting yourself in case you know, this Lambda function is compromised. You don't want users to have all sorts of permissions to do things with your AWS account. So always least privilege. So that's what the role is for, and you'll see this role is actually being used here inside this pre-signer Lambda function I was talking about. But it's also being used by our other Lambda function down here. And there's a key difference between these two Lambda functions that I do want to talk about. This is one Lambda. This is a standard Lambda function. You're saying, well, this is going to be a Python runtime. I'm going to run my Python code. But down here, I purposely try to do it in a different way. This one is a Docker-based Lambda function. A Docker-based Lambda function just means that it's going to, instead of uploading my code, it's going to create a Docker image and use that Docker image when it runs my Lambda function. Why would I do that in this case? Well, let's take a look at what this code actually will. Well, first of all, let's take a look at what this, I never actually defined where my code is. And that's because it's going to utilize my Docker file over here. And this Docker file is what's used to build the Docker image. And over here, you'll see this is where I've defined where my code is. So my parser.lambda handler. So I'm going to again go here. This is my parser. This is my Lambda handler. And this is, again, if you remember to what we're trying to build over here, we're trying to build a website where we can upload a file and then parse the file to return an array that we can basically render on the UI. So this is over here, again, a very simple Lambda function where we read a file from S3. So we're reading the file from S3. We're loading the NumPy array and then basically returning the array in a JSON object. But the reason why I chose to put this in a Docker function is because I had to install the NumPy library in order to do so. Now, where's my Docker file? So you might have noticed in my Docker file, before I actually said what file to that I want to include, I asked it to install the requirements file. So my requirements file, just like any other, like most Python projects, you're saying, hey, these are all the libraries I want to include. So in this case, I want NumPy 122. So I said, okay, I'm going to install my requirements to this particular location. so the benefits of my Docker image is that it's going to not only upload my code, but it's also going to upload the dependencies along with my code. And it's a Docker file, so you can actually imagine you can do a whole lot more. So you can include additional files if you want. You can include multiple files. You can have a really long list of requirements. So actually, one thing that would be interesting to do is that if you're building a inference inference Lambda function where you want to run a machine learning model, then this is also I can extend this. I can say I want Torch as part of this as well in order to load my machine learning model. And so you want to deliver all of that in Docker image instead of doing it in the other format that I described. So this is a typical way you would do it. But the benefits of the Docker image is that first of all, you have everything prepackaged up. And then the second of all, you actually get to include all these other dependencies up to 10 gigabytes. If you do a standard Lambda function, there's a limit on how large your code that you upload can be. I think it's like 256 megabytes. But as you know, the Torch dependency itself can be easily hundreds of megabytes in size. You actually cannot include all of your Torch dependencies in the standard Lambda method. And so that's why the benefits of the Docker image method is that you can have you can bundle your code together and have a lot more space to put your dependencies. Okay, I talked a lot. Any questions so far? Taking silence is a no.
Tom, could you talk about this,
Yes.
The log retention parameter?
Oh, for sure, yes. So actually, let me pause 1 second and let me actually, I'll show you that once our resources are deployed. I'll show you that on the website here. And I think it has just finished deploying. So if you go back to where my terminal, if you remember in my terminal, I ran a command. Oh no, ran a command earlier to say, hey. And the reason I did that because the command takes like 8 minutes to run. So I ran the Cdk Deploy. Sorry, this is a bit small. So I ran the Cdk Deploy command. This basically takes my blueprints, as I mentioned, creates all these on AWS. Actually, as part of it too, it's actually going to, create my Docker image as well. So this is just a log output. So you'll see it. I'm just going to skip over most of it. This is where it's asking me to say, hey, these are all the things you're about to create. Are you okay with it? I said yes. So it's going to, this is where it's creating the Docker image. I publish my everything. It's creating my change set. So after, what is that? 5 minutes, it finished creating. And so I'm going to head over to my AWS account and I'm going to see how it created it. So first of all, I can also see the same deployment steps on the UI. So this is my blueprint. You'll see this ED monitor backend stack, which should be the same name as what I called my CDK stack over here. I said I wanted to deploy it in US West 2, which is Oregon. And you see it successfully created a couple minutes ago. So I'm going to go back to my events. You can see this is all the steps that it took. You can see, it's creating my VPCs, it's creating my Lambda functions, it's creating my, these are all VPC steps. It's creating my API gateway, which I realize I didn't talk about, but I will get around to that. So yeah, so all of these are steps that it took. It created successfully, so we should be able to see everything on our, if I went to respective pages. So my bucket, for example, I said I created a bucket. So if I refresh it, I should see my new bucket. So this is the new bucket. You can see it was created 12/19. This is the bucket that it created. It is currently empty, but I don't know if you can see the encryption setting here. Oh, no, you can't see it yet. Here it is, sorry. So I said one of my properties I wanted in my S3 bucket was that it had to be S3 managed encryption. So if I go here, we say, yes, it's properly set the S3 managed encryption setting. And so obviously you can do a lot more over here. You can redeploy your stack if you wanted to, say, update the encryption setting. So I would then, maybe change this to KMS managed and redeploy it, and then this property will change. But I'm not going to do that right now. We're going to take a look at the Lambda function, because this is one of the things that Pranav, you asked about. So the two Lambda functions I created was, they're poorly named, or these two. One is called the query function. This is the Docker-based Lambda function. This is the other pre-signer one. I didn't actually give it a name, I think, so it generated a name for me. But this is this one. This is the log retention thing that's automatically generated. But I'll talk about what the log, where was the log retention down here? I said it's 3 months. So if I went to the parser query function, we should have it should have put a setting over here on logs. Let's see, general or monitoring operational tools. Let's see. You know what? I have no idea where it puts the settings on. Is it in here? Here it is. Retention 3 months. What this basically means is that, so if I run my Docker, if I run my Lambda function, right, it's gonna run this function, and if I print any, if I have any print statements, let's see, parser function over here, do I have any print statements? So I have a print statement like this, right? So these are going to be generated and stored in here. So this is, you can see what I was doing yesterday. So while setting this up, you can see that, hey, look, this is one of the log lines. So starting parser with this bucket and this file name. So you can see this is the log line. If you don't set a log retention, it's just going to retain it forever. You actually pay for the logs. And so oftentimes you might set a retention saying, I want to delete it after 3 months. One of the things to watch out for nowadays, and it's a big thing that our team works on at Amazon, is compliance with a lot of governmental regulations. A lot of countries now are tightening their data privacy regulations. So in India, for example, they have these data locality clauses, which means that any personal data that you generate must be, first of all, must be done in their region, must not leave India, and they set like requirements on how long you're able to retain this personal data. So log retention is also something you have to keep in mind, because imagine that you've built a function that takes in some, I don't know, patient IDs, and you logged it. You've like printed it out, as a patient ID. That is actually personal data, and the government can come after you if you don't abide by those regulations. Say you stored it in your logs, but you never deleted your logs within, say, 18 months as they prescribe, then that's something that you have to, they can like issue fines or whatever procedures that they've listed out. So that's why log retention is also useful. It's to clean up old data, but it's also useful for staying in compliance with regulations.
Just on that note, let's say you change this from 3 months to some other, and you executed this backend stack again. Does it create new Lambda functions? Does it modify the Lambda functions you have?
It modifies the Lambda functions. And so that's exactly what you would want to do in an industry setting where, everything here is in my code repo, right? So my GitHub repo. So if I made a change and I changed this to be, I don't know, 1 day, for instance, then I would get a pull request. I would get someone to review this, my teammate to review it. If we're okay with it, we push it. We deploy the stacks again, and these settings will be updated.
And you could have also modified this setting on the UI, right?
You could have modified it from the UI, but that's not, we would, like in practice, we would never, our AWS console is very locked down. Like you would never want to go in and touch your AWS console, because that means any changes you've made is untracked. And so it immediately means you've diverged from what your blueprint says, and that's really bad. It's also a lot of, I work on a finance team, and so there's a lot of like, governance and risk compliance measures that we put in place to prevent us from modifying data. All right, so I talked about the Lambda functions we've created. There's just one more piece down here, which is the API gateway. So this, going back to our architecture again. So we talked about CloudWatch, which is what our logs are basically stored as our log storage. We've talked about our S3 bucket. We've talked about our Lambda functions, but everything here is not accessible to the internet yet. So we're going to make it accessible by setting an API gateway. Our API gateway is basically a REST endpoint that we've created. We're saying, we can, we're going to create two endpoints, one for our pre-signer, one for our parser. They both get endpoints. So this is the API gateway that it created for my blueprint. You'll see it has a parser, get, pre-signer, get. And so basically, if I call these endpoints, it's going to trigger my Lambda function. And let's test that out right now. So let's test out my get endpoint. So I'm going to test this. I'm going to call it, if you go back to my Lambda function, what is this, pre-signer? It's going to take in one parameter called name. So name equals, I don't know, AIHC. I'm going to test this. It says 200, okay. What this Lambda function, remember, it returns like some temporary credentials for you to upload some files. So that's why this bunch of junk is returned. But the important thing I want to show is that this is an API that this API gateway, this API calls my Lambda function. So if I went back to my pre-signer Lambda function, I went back to my monitoring. If I looked into the logs, it should show me that immediately I have a new log message say, hey, I've called it at 12:38 with, so basically I've successfully called my Lambda function and printed out some logs. So that's one way of testing your Lambda function. You can also run it locally as well, but I'm not going to show that. So going back to my API gateway. So I have my API gateway component ready. This is perfect. And this API is publicly accessible. And I can actually see that because I think if I click this, this is my public API link. So, you're not hosting it on your own server, so it doesn't have like a nice URL, but it's a private, you want your APIs to be kind of private. So, it's kind of security through obscurity as well. Of course, you can put access controls onto this API, which I have not done, but this is a public API that we're able to call. And I'm going to now incorporate it into my website. So I spoke for 40 minutes, but I have not actually shown you what that website looks like. So now we're going to move to the front end. This is a very simple React website. So I'm going to go back to my terminal. I'm going to go to my front end. I've already installed all my dependencies. So now I'm just going to run start. And so this is going to launch a new server. This is just a very simple React website. It contains very little on it. So while that's loading, I'll just show you the website. It contains basically one page. This page is contains, like a header, it contains a element to upload files, and contains a line chart to display our ECG that's returned. So this is what it gets rendered as. Do you guys use React a lot? Is that something that's everyone's generally familiar with? No. Due to time, I don't have a chance to go into depth, but basically a React website, the website is powered by state. So it means that, if you, this is where all my state is located. And so I can, let's see now, I can add a new field, say day of week. What day is it? Tuesday. And then I can have access to this state down here. So if I wanted to say another line, I can say state.day of week. If I save that, you can see, it's updated automatically. And so by modifying, the whole point of modern web development is that it's driven by state. So if I modify my state, the UI is going to change at the same time. So, right now I'm just manually updating it. So I save that. It's going to update to Wednesday. But if I have code that dynamically changes the value of this field, then the UI will change at the same time. So that is essentially what we're trying to do with our waveform. Our waveform array is currently empty. And so nothing here is displayed, but our goal is to be able to call our API with our uploaded file, get back that JSON parsed. Remember, our Lambda function is meant to read the NumPy file and just return it as a normal JSON array. So that's what this function is going to do. It's going to call our API, get back the array, and we're going to just save it to this waveform field over here. So hopefully we're going to get back an array after I call my API. So there's a few things I need to change from this default website. Is of course I've created a new API. I just launched it like 10 minutes ago. So I need to take my URL over here. And I'm going to replace whatever's here already. So you see we have, this is from my previous testing. So I'm going to replace that. So I've replaced these two. Nothing else here needs to change. And so if I save that, this website hopefully is now hooked up. So sorry to repeat again. So right now what it's doing is that there's an upload container. So if I upload an ECG, it should call my, it should upload it directly to S3 because I've already retrieved my temporary S3 credentials to upload to S3 by calling this API gateway, which calls this Lambda function, which returns the temporary credentials. And so this is kind of automatically hooked up by this library. And then once it's uploaded, it's able to then call my getWaveform method, which again is going to call my Lambda function that will take my array, parse it, return the JSON object, set it to this property, which will update the UI. So hopefully this works. I do not know if it's going to work or not, but let us see. So let us, oh dear, where did I put the files? So this is an example. So I upload this, hopefully it does not fail. And so there you go. If we look at our network, we'll see that it made two calls, one for the pre-signer. Again, this is the same thing I demonstrated on the API gateway. It returns the, the temporary credentials that allows you to upload to S3. Once it's uploaded So you can see over here, it's actually uploading the file directly to S3, my S3 bucket that we just created. And then finally called this parser function, which is my other API, and it's going to return a very large JSON array, and it sets it to the waveform properties and it renders on the UI. Any questions so far? All right, still with me? There's like one more component I want to demonstrate, and then we can see if you have any more questions. Basically, I'm happy with how this website works right now. We're saying, hey, I'm gonna get, oops, where's my mouse? But the one thing is, of course, it's running on my local host. It's running on my own computer. So how do I get this publicly available? Well, this is where I'm going to go back to Amplify. And I'm going to use Amplify's web hosting capabilities. So Amplify is a set of tools and platforms. The name is kind of overloaded. Web hosting is one of its capabilities, but it also has, like a JavaScript library, for example, that allows you to include things really easily, such as, say you wanted a login page for your website. It has a library for that, and that login basically is going to take advantage of other AWS services to handle that login experience. Because you imagine login is actually really complicated. You need to do email verification or phone number verification. You need to like have a forget password link. So all of those things, you don't really want to think about if you're a developer. You just want to get like a prototype website out. And so that's what Amplify is meant to do. It has a set of libraries which you can use, add authentication, for example, and it's going to take care of that for you. It has its own kind of like blueprint, as I mentioned. It has its own blueprint. It's going to set up a few resources for you in your AWS account. Things like Cognito, which is going to store your user credentials. It's going to set up probably like some kind of endpoint for you to like, I don't know, reset passwords and all of that. So all of that will be taken care of for you. But today, we're just going to use its very simple web hosting capabilities. So I am going to connect this to my GitHub account. I didn't commit my codes. You won't see everything, but I'm just going to make sure this code over here gets, the front end code at least, gets hosted on Amplify. So I'm going to say continue. I'm happy with my GitHub integration. So this is the repo. And I'm happy with my main branch. I am gonna, my website, it's my front end, it's stored in the front end folder. So I'm just gonna say, yes, it's in the front end. It's gonna grab some settings. I keep everything as default, and I'm just gonna deploy it. This will take a few minutes. But this means like once I've set this up, everything is hooked up end to end, which means that once I make a change to my website over here, I push it, Amplify is going to detect that there's been a change, and it's going to pull the latest changes, build it, deploy it, and make it publicly available. So this is a more modern paradigm of web hosting. Traditionally, you rented your own server, you installed your own maybe Apache server, you hosted your code there, but of course that has scalability issues. Say you were Coinbase and you decided to launch a QR code for some reason at the Super Bowl, and you had like 10 million visitors at one point. Your one server is not going to handle that. It's going to crash. And so the benefits of doing something like on Amplify or like these serverless, I talk about a lot about serverless today. It's just because it gives you the scale when you need it, but you only pay for what you use. So because you're hosting on the cloud in a serverless manner, you have the capabilities to scale kind of like infinitely all at once. And so you don't have to worry about, oh, I need to go order more hosts, spin them up, add a load balancer. That all this is done kind of for you, and you're just kind of paying for what you use. So yeah, so this is what it's going to be doing. It's just building. It's doing exact same thing as I did on the front end, installing the packages and building like a production ready version of my website. So yeah, once it's finished building, it's going to be available at this link. You can add a custom domain. So right now it's going to give you a generic link, but of course, if you add your own domain name, you would point it here. Yeah, I think that's really the main things I wanted to hit today. Any questions while we're waiting for this to build? Otherwise, I think it's almost finished building. There we go. So build completed, deployed. So that means if I go to this website, hopefully it means I have access to, yeah, all right. So this is a publicly accessible website. You are able to try it out as well. Where's my mouse? So my mouse keep doing that. So I think you can download this file and you can upload this file and, oh, no. Name not result. Oh, sorry, I didn't. We made some changes. Hey, look, we're gonna try this out. So I made some changes. I uploaded, I changed the API gateway name. So I'm gonna commit, update API gateway. I'm gonna push my changes. And hopefully this means oh shit. It kicked off a new build because it says, hey, I've detected that you have some new changes. And it's gonna, well, I guess it's gonna take another couple minutes to build and deploy our changes to this website. But once it's deployed, then you're able to use this website as I did locally.
Tom, this was amazing. Thank you.